Hi, welcome to single linkage to compute the distance between two clusters, which is used to calculate the minimum distance between different clusters. Here we are making five individual data points, so each one is working as a different clusters. So we are having five clusters here: one, two, three, four, and five. Okay, so now we will apply the Euclidean distance metric to calculate the distance between each and every data point. So here we are going to calculate the distance between 1 and 2, 1 and 3, 1 and 4, and 1 and 5. Like that, 3 to 5, 3 to 4, 3 to 2, 3 to 1 already calculated, not needed. So like that we have to do it. Okay, when you are taking that, so here from the 1 to 1 there is no distance, so which is 0. Then from 2 to 1, so 2 to 1, this distance metric, so we will apply the Euclidean distance. You look at that, for 2 comma 1, 0.07 x1 minus x2 whole square plus y2 minus y1 whole square, we are getting 1.04139, which is the distance given here. Then you have to calculate the distance between here 1 to 3. So 1 to 3 is this one. Okay, so now 3 to 1, 3 to 1. Okay, 3 to 1 we are calculating, so we will get the 0.59304. So here again we are getting 3 to 2, so 3 to 2 this one. So like that we can calculate. So why we are not calculating this one? In the sense, here when you are calculating the distance 1 to 2, so 2 comma 1 also, 1 to 2 is also same value what we have here, 1.04139, and here 1 to 3 will become 3 to 1, so this value, so 0.59, etc. Right, 1 to 4 will become this 4 to 1, this one, so 0.46098. So the values are repeated after the diagonal of the given table, so we need not to repeat the values, so we can cut the top, I mean that corner portion, upper corner portion of the given table. So these are all having repeated values. So after calculating the Euclidean distance between each and every data point, we have to observe which is the minimum distance value available, this value. So here when you are taking all the values, 0.30232 is the minimum distance. So these two data points are close to each other, these two data points are close to each other. So you can make it into single cluster, combine the 4 comma 3, right? So we are combining 3 comma 4 both data points. Then now we have only this is having the 3 comma 4 data points, 1 is available here, 2 is available here, 5 is available here. So we are having 4 clusters now. Okay, again you have to calculate the distance matrix, right? So when you are applying the distance matrix here, you will get d3 comma d4 to d1. Okay, so this one, this value, right, this value is 0.46098. then d3 comma d4 to d2, right? So this one is 1 d2. Okay, so this one, okay, 0.61612, right? Then distance between the cluster d3 comma d4, d5. So this is d3 comma d4. Okay, this one. Then d5, so d5 is the data point, this one. So here this one. Okay, so here only these values are updated, only these values are updated. Okay, so now you look at that, these values are updated. Now the remaining values, this one, and 0.32 are already existing, we are not at all updated, because wherever the cluster is updated, only that data points, that cells are updated now, that cells only updated now. Okay, so after updating we have to identify the minimum distance among this all the data points. So here 0.3238 is the minimum distance between all these 6 values. So these values are related to fifth data point and second data point distance. So we can combine this second data point and fifth data point, so it will become single cluster. So now we will have like this, appearance. So here this data point is 3 comma 4, this data point is 2 comma 5, cluster 1, cluster 2, this is another cluster 3 which is having only one data point. Okay, data point number 1, right? So now we will apply the Euclidean distance to calculate the distance. So when you are calculating this, here after combining your values, 2 comma 5 is there, here 2 comma 5 is there, so only these values has to be updated. Okay, so 3 comma 4 is not affected, right, with 1, so this value already affected, so we have to calculate this one, and this is also affected, right? So we have to calculate this one, so this is updated. You look at here, this is 2 comma 5 to 1, 2 comma 5 to 1 is 0.81 41 841. So here 2 comma 5 to 3 comma 4 is 0.35847. So now we have to observe which is the minimum value. Here minimum value is this 0.35847 among this, out of these three values. So now we have to merge 3 comma 4 2 comma 5 2 comma 5. So we will take 3 comma 4 and 2 comma 5 into one cluster, right? 3 4 comma 2 comma 5, then one more data point is alone two clusters. Then we have to apply the distance matrix to calculate. So now we got 0.46098. So only one data point available, we can combine the data point with this one. So finally we will get all the data points in the single cluster by using single linkage. After this we have to draw the dendrogram, tree like structure based upon the distance. First it is taking d3 comma d4. So this is the data point d3 comma d4. The distance is here given in this y-axis, so 0 point, okay, this is the distance 0.30, okay, this one. Then distance between d2 comma d5, so this one here the distance is mentioned here 0.32, okay. Then distance, so now two clusters are formed, so this is one cluster, this is another cluster, okay. So now we are going to combine d3 comma d4 and d2 comma d5. So this cluster 1 and cluster 2 going to combine. So when you are combining that, so here this is the two clusters are going to merge. The distance is this portion, okay. So 0.35, okay, here 0.35, right? Then after combining this so cluster, so now again we are having one remaining this one, and this is one big cluster. Now we are going to combine these two with the distance 0.46098. So that is mentioned here with the distance 0.46098. So the dendrogram is used to expose the or express the distance between different clusters in the given model. Thanks for watching.